PulseBoard's primary database is durable and correct, but feed reads are growing. The team adds a red replica. A post commits successfully, then the author refreshes and does not see it because the read went to a replica that is 2 seconds behind. Nobody corrupted data. The system kept 2 useful promises and failed to define a third: read your rights. This is why system design starts with user-visible semantics. Before discussing SQL, NoSQL, or graph storage, decide which facts must be consistent, which reads may be stale, and how the application signals a temporary difference. A primary replica layout has one authoritative write path and one or more copies that receive changes. It can increase read capacity and provide a recovery option, but replicas add replication lag and failover rules. PulseBoard keeps post creation on the primary. General browsing may read a replica. Immediately after publishing, the author reads from the primary or receives the created post from the write response. This targeted rule is cheaper and clearer than demanding strong consistency for every feed read. Measure replica lag and treat it as a product-relevant metric, not a database detail. Relational storage is a strong fit for PulseBoard's accounts, posts, follows, and payments because constraints and transactions protect linked facts. A document store can be useful when a record has flexible nested shape. A search index can support full-text discovery without becoming the right authority. A graph representation can make some relationship traversals natural. These are not mutually exclusive identities for an application. They are tools with operational cost. Start from the access pattern, write invariants down, and introduce another store only when its benefits exceed the synchronization and ownership burden. Eventually, one write authority may become the constraint. Sharding partitions records across independent database groups. For PulseBoard, a common key is user identifier because an author's posts and settings then have a natural home. But a trending topic feed crosses many users, so it becomes a scatter-gather query if you did not build a separate read view. A good shard key distributes load, keeps common transactions local, and matches recovery boundaries. A bad key creates hot partitions or forces every request to ask every shard. There is no universally correct key without a workload. In the local simulation, a post enters the primary at time 0. The replica receives it 2 seconds later. The author's next read uses a short-lived read your rights token and reaches the primary, so the result is immediate. A different reader uses the replica and sees the post shortly afterward. Next, the simulator routes 4 user identifiers to 3 shards. One popular topic query touches all 3, while an author profile query touches 1. The screen makes the cost visible. Consistency, partitioning, and query shape are decisions viewers can reason about, not invisible database magic. A replica is not a backup, and a backup is not a tested recovery plan. Record the recovery point objective: how much recent data could be lost under a severe failure. Record the recovery time objective: how long the user journey may be unavailable. Practice promotion and application reconnection in a safe environment. Protect backups with access controls and retention rules. Design for a primary that becomes unavailable, a replica that falls far behind, and a migration that needs rollback. A database architecture is only production-ready when its failure behavior is understood as well as its query speed. PulseBoard keeps relational storage as the authority for important facts. It uses replicas for eligible reads, an explicit read your rights path after publishing, and a documented partitioning plan only if measured write load requires it. The next challenge is work that should not happen in a user request at all. In Episode 5, publishing one post triggers several follow-up actions, and a queue lets the system be responsive without pretending every downstream task is instant.